Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT One. And our guest today is Sastry Malladi, CTO and co-founder of Foghorn. Foghorn delivers comprehensive data enrichment and real-time analytics on high volumes at the edge by optimizing for constrained compute footprints and limited connectivity. In this talk, we discussed the business value of machine learning on the edge and the need for hybrid edge cloud architectures. We also explored technology trends that will increase the usability and functionality of edge computing systems. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iot1.com. Thank you. Sastry, thank you for joining us today.
Sure, it's my pleasure, Eric.
So Sastry, we have a slightly technical topic today. So how cloud-dominated solutions will adopt a more edge-first or cloud-edge hybrid approach. But before we get into the technical details, I want to understand more where you're coming from and also the background to Foghorn. So starting from your background, I know you're now the CTO of Foghorn. I believe you've joined about 4.5 years ago. How did you come to end up at Foghorn? What was the path that led you to this company? And what was it about Foghorn that made you feel like this is a company that I see high potential in?
Absolutely. So yes, I am a co-founder and CTO of Foghorn. It's about 4.5 years plus. I'm an entrepreneur at heart. I've got a technology background, both in the leadership roles as well as the executive management roles for the past 3 decades or so. On and off, both big companies, startups, self-funded companies. Primarily, my background has been starting from hardware devices, operating systems, applications, networking, slowly walked back up to application services, big data, and so on. How I got interested in Foghorn about 4.5 years ago is when our seed fund investor, the Hive, which is based in Palo Alto here, they typically set aside some seed funds and try to look for founders for solving certain problems. One of the problem areas that they wanted to solve was in the industrial IoT space. And they've been looking for founders who can come and help to go build this technology to solve specific problems. We'll get into context of what we're actually solving in a second. But that's how they started talking to me for about, I'd say, 6 months or so. And then our other co-founder, David King, also came on board around the same time. And that's how I ended up in Foghorn and never looked back. And I've been enjoying since then. We're actually building a pretty cool company to solve a real problem for industrial IoT customers.
Okay, but that's interesting. So it was actually a seed fund that had a problem that they thought needed to be solved, and then they basically recruited you, or they scouted founders that they thought would be able to solve this. That's it?
Exactly right. And the way it works is that once they recruit us, then they leave it to us. We actually go raise the funds, like Series A. We started with Series A. We're currently, we've just recently funded closed Series C last November, but the A, B, and C. And then we basically hire the rest, the team, build the product, take it to the market, build customers and so on. So we take it from there. Effectively, the seed fund company helps us to bootstrap this, and then we take it from there. That's really how their model works.
Okay, and I'm sure they're happy with the results. Foghorn has great traction right now.
Yeah, absolutely. So far, so good.
Did you know David before you co-founded the company with him, or?
Actually, I did not. I met him. I started talking to David when our seed fund company introduced us.
And tell us a little bit about what Foghorn is and what problems you solve before we go into the technical details. Just what is the value proposition behind the company?
Right. So if you look at the IoT, I know IoT is a buzzword. A lot of people use that. But if you look at specifically in the industrial sector, whether you're talking about manufacturing, oil and gas, transportation, across the board, and problems do occur, right? So there is potentially the yield improvement issues, scrap issues, or predictive maintenance issues and all of that. Up until now, what they've been always doing is trying to somehow collect some data information about those assets that they're trying to monitor to optimize for their assets and the business outcomes, and then somehow maybe ship it to the cloud environment, do some analysis and try to find what the problem is, right? That has not been working really well for them. It's not only not cost effective, but it's also not practical to send all of that information into a cloud environment and process it there, and then send the results back into the asset. And by the time they do that, perhaps whatever issue they were trying to solve, maybe the machine is down, maybe the part that they're manufacturing was bad, that would have already happened. It was too late, and they wouldn't have helped them. So what we set out is to solve exactly that problem, which is to say, how do we enable these customers to figure out problems in a proactive, predictive manner, meaning that some time from now, the machine is going to fail, or the parts that are going to be coming out are going to be defective. So we raise automatically an alert to the operator so they can fix that. With the simple goal of optimizing the business outcomes, reducing their scrap, improving the yields, as well as doing some predictive maintenance and things like that. That's the fundamental premise. Deriving actionable insights that will help the business outcomes. That's really what we do. Obviously, there are lots of challenges in doing that. That's where we had to go invent our technology, and that did not exist before, which is to say that there are constraints because you're working in these constrained environments, and typical existing softwares that exist do not run in those environments. So we had to come up with an innovative way to do this on the live data that's coming in from these assets. That's really how we got started.
And you're purely software, right? So all of the hardware involved, you'd be working with partners.
That is exactly right. Purely software, but as you can imagine, as you probably have seen, we have lots of investors that are also hardware partners. Like Dell, for example, is an investor and a close partner. HPE, not an investor, but close partner. We've got Bosch, and we have AD-Link, we've got Advantech, number of hardware partners that we closely work with, and then we certify, but we don't actually sell necessarily any hardware. In fact, these hardware manufacturers have their own catalog of SKUs where they preload and test our software. If a customer actually wanted to buy their hardware plus our software, we do have that kind of bundles or packages made available one way or another.
Okay. Yeah. And actually, that's a great business model, right? I mean, as a younger company, building up a sales force to reach a broad market is quite challenging. So having HP and Dell and Bosch and so forth, being able to bring your solution to the market, I imagine that's the right way to enter. On software, I guess we can kind of divide the software into the, let's say, the architecture elements around how you process data, capture, process, manage data, and then the specific application. So every customer has their specific problem, and I suppose those applications in some cases are somewhat standardized, but in some cases there's going to be some customization around the requirements. Are you typically doing both the underlying architecture and the application, or would you in many cases provide the architecture but maybe work with a third-party software provider that has an application for a specific problem?
That's actually a great question. Let me take a couple of minutes to explain that. Our fundamental business model is an annual subscription software, right? We provide the software, which is a core engine where customers can install that software onto either the existing devices. Remember, our core IP here is the ability to run these on constrained devices, whether you have an existing PLC, whether you have an existing small ruggedized Raspberry Pi-like device, or some cases the asset itself, right? We can fit our software in small footprint compute environment. But once you do that, you can configure the software with all of their local sensoring information, and program using our tools as to what it is that they're trying to detect and what specific problem they're trying to solve. Now, what we have learned early on when we started shipping this product back in 2016 to our customers is that many of these customers, because they're industrial in nature, they're not necessarily technology focused. And therefore, they would come and ask us, can you help us to also, not only, install, but also actually, help configure, program your tools so we can detect the problem we're trying to look for. And we started doing that. Obviously, as an early stage company, we had to get into these customer accounts. We started doing that. And soon we have realized within 12 months or so that since every single customer has been asking for it, we've got to find a real solution for it. And we solved that in two ways. One is we started building an internal data science and technical services division to help with that. Like initially, if you want to do a pilot, if you need a couple of our data scientists to go help initially use our tools to help set you up and all of that, we can do that. Many customers continue to do that. We've also established a huge slew of partnerships, ecosystem across the globe, starting from large SIs, all of the Wipros, Indian SIs, as well as local, American SIs across the globe as well, like Accenture, Deloitte, and Wipro, TCS, a number of those guys. Those are all our partners. They are actually familiar with our software. We have trained them. They're running it in their labs. So when a customer actually comes to us or to them, frankly, for looking for a solution that requires our type of technology, and they can handle that as well. But we do have an internal data science division that also helps with a lot of the pilots. Now, one other point I'll make before I pass it back on to you, Rick, is that what we have done in the last 4 or 5 years is that we have done a number of such pilots with many Fortune 500 customers, and then we began to identify what are some of these repeatable, commonly used use cases across, and we started packaging them together so that neither the customer nor us, nor a third party needs to go and do any customization per se, but they would get the packaged out-of-the-box solution, install it themselves, and then fine-tune it using our own UI, and then get it up and running for these commonly used use cases. And that's where we're finding also a lot more traction these days in the last 1 year or so.
Okay. In these packaged solutions, you'd be developing those in-house, potentially with a strategic partner. Is that the case?
Not with a partner necessarily, for software is wholly developed by ourselves. And then we do have strategic partners. For example, let's say we're developing, we'll get into use cases in a second, developing a solution that requires a camera. We've got partnerships with camera vendors, starting with Bosch and a number of others too. Let's say that solution actually requires a few sensors. Somebody actually wants to install and buy sensors too. We've got partnership with sensor vendors too. So it all depends on it, but our core package solution development included software itself is done in-house. And then the partnership comes to when it comes to bundling the hardware.
Okay, very clear. Let's then cover use cases. What would be, let's say, the top 5 use cases that would typically be relevant for Foghorn?
Use cases, before I say that, just one word, right? So we are a generic platform engine. That's how we started, using Edge, ML, AI. Those are all some of our trademarks too. Being able to run machine learning and AI in a constrained small footprint environment. And of course, traditional analytics and CEP-based analytics too. That's our core engine that we built from ground up. We've got several patents on that granted as well across the globe. Now, use cases, initially we started off, obviously manufacturing. We started doing both process and discrete manufacturing use cases. Almost all of them can be categorized into either a yield improvement, scrap reduction type use case, meaning that the machine itself is manufacturing a particular part or a product, and that product comes out to be defective. And then our software is trying to predict and detect ahead of time before it produces defective parts and then fix it. That's one type. The second types of, and many types of machines, whether the CNC machines or pumps, compressors, a number of types of assets. It doesn't matter, regardless of what type of asset you're talking about, doing a predictive analysis either for the parts that come out of it, or secondarily, the process itself. If there is actually a problem with the process and how, maybe it's not feeding the parts appropriately. Maybe the inputs themselves are wrong. Maybe the temperature control is wrong. Whatever the process issues are, we can detect that as well. That's a couple of types of use cases we've done in the manufacturing side of it. And we'll give you specific examples when we get to case studies. And switching to a different vertical, like something like an oil and gas, in that, the types of problems are different, which is to say, starting from the upstream, downstream, and midstream use cases. When you're drilling for oil, there could be a number of issues. For example, potentially there is a blowout prevention optimization that we need to do, or there is contamination of fluids as they're drilling that you may need to stop, or there is flaring. For example, as you're refining the gas that you just drilled, and potentially due to compressor problems or some other problems, there could be a phenomenon called flaring, where you start releasing these gases into the atmosphere, causing emission problems and EPA regulation violations and penalties and so on. We can actually predict and proactively prevent and be able to do that and monitor that if that is exceeding certain thresholds and take care of that too. And then there are other types of problems where you're drilling, for example, there's a problem with the drill bit, or there is an issue with steam traps, there's an issue with something else. A number of types of use case, leaking gas, leaking moisture analyzers, things like that. Types of use cases vastly vary within that sector as well. But again, you might be wondering, how we can take care of such vast majority of use cases. Remember, fundamentally, the way to solve a use case would be to install our software, configure, auto-detect the sensors, and use our tools to specifically program what you're trying to detect, unless it's already a packaged solution available for us. And then we're moving on to the transportation, which is another vertical that we're working on. The types of use cases there are, again, efficiency and optimization of the asset. We started with locomotives initially, GE, which is also an investor in us early on, and they had the locomotives installing our software within the locomotive itself, being able to optimize and predict fuel efficiency conditions, intruder detections, wear and tear of this equipment itself, things like that. And then we moved on to fleet management, especially for trucks, monitoring the driver behavior, something called reason condition, to all the way to the autonomous driving vehicles. Now we're working with companies to actually install our software inside their vehicles. This is actually publicly announced. Porsche was one of our customers. We have done a number of use cases there. We can talk about those as well. So as you can imagine, the types of use cases vary from predictive maintenance, proactive failure condition detection, to condition monitoring of assets in all of these three different sectors. And lately, I'll say one more thing before I pass it on to you. We've been also getting into energy management use cases, especially in buildings, smart buildings, whether they're office buildings, whether they are school buildings, whether they are hospitality buildings, regardless. Also partnership with Honeywell, we're actually we have a solution now to optimize the energy consumption in those buildings by simply running our software and connecting those sensors and programming to detect those conditions and things like that. So it's a gamut of use cases that we've been after.
Quite a wide variety. So I imagine that even though you are bringing your own kind of integrated solutions to market or more standardized solutions to market, in many cases, there's some degree of customization required. If you can give me kind of a rough estimate to what proportion of your customers are able to do this in-house, and what proportion require some external support, whether it's by you or by a third-party system integrator?
Yeah, if you ask me that, say up until last year, right, majority of the portions of our customers were using some help in one shape or form from ours, first to either to customize that or to build a solution for them or to leverage an SI. But in the last 12 months, that picture is changing quite significantly, rapidly, which is now that we are actually started releasing these package solutions out there. Those customers that are actually buying these package solutions no longer have to depend on any services support from us. We're actually coming up with part of that package solution would be like a UI, which helps them. I'll give you a simple example. Let's say you're talking about flare monitoring, right? So flare monitoring, this is a vision-based ML AI system. So we take the video camera feed, we take the compressor sensors and valve positioning, all of the different sensors. And then we build, for example, the package solution will have a machine learning model that's processing this flare images to identify certain KPIs. Now, obviously, when you take that solution to install in a different customer environment, maybe how their flare looks is slightly different. Maybe the conditions are different. Maybe the camera positioning is different. Maybe the resolution is different. Something else is different in the environment. And therefore, in order for that solution to accurately produce those KPIs, they will have to fine-tune that specific to their environment. And to do that, rather than they hiring us as for services arm or going to an SI to help with that, we've actually built a UI where they can come in, for example, upload their video, upload their parameters, walk them through, how to fine tune that, and then self fine tune and recreate the solution there from the deploy, right? So in other words, in the last 12 months, the number of customers beginning to depend on our services is reducing. But in the first few years, it's pretty much vast majority of them, although there were quite a few of them also doing it on their own.
Okay, great to hear. Yeah, that's a very positive trend that we've been seeing is companies making the interfaces much more, let's say, comfortable for a non-technical user to modify, right? So
that's exactly right. If I may say something, Eric, something I neglected to mention before, one of our core strengths of our offering is also we are actually OT-centric, operational technology-centric. As I mentioned early on, a lot of our customers are not really highly technology savvy. They're all engineers, but they're all engineers from a manufacturing mechanical standpoint, but they're not necessarily computer science engineers, right? So if you go and ask them and tell them anything in terms of programming, complicated thing, it's going to be really hard for them. So we started building from the get-go what we call this OT-centric tools, drag and drop tools where they can drag and drop a sensor definition, identify and explain or express what it is that they want to derive. And then we take care of the coding business behind the scenes. So we definitely take pride in that, which is it's really, really important to put out OT-centric tools as opposed to IT-centric tools in order for us to be successful in this market.
Yeah, that's a great point. I was just going to ask you about who's the buyer or the system owner, because I suppose 10 years ago, it would be IT, but it sounds like that's not the case here. So is it then the engineering team? Is that who you'd be working with, or who would be a typical buyer and then system owner once the system's operational?
Yeah, so it's actually another great question. Typically, the user, maybe I'd split that into two parts. The user of our software is the actual operator, the engineer that's in the plant environment or a refinery environment or a vehicle or whatnot, right? So those are the users of the system. But obviously, the person who has got the budget, who actually buys it, is somebody, their CIO, CTO, whatever is the role is, right? Now, unlike a typical IT sale where you go and convince the budget owner or the CIO or the CTO for the budget and go sell this, and then everybody start using it, that's not as simple in these environments, because the person who actually owns the budget, who has got the money to buy this, is not the same person or the same team that's actually trying to use it. So we have to bring both people onto the table to make sure, convince the operator, convince the engineer that this actually does solve the problem to them. And of course, if you don't have the budget, it doesn't help even if the engineer thinks that, operator thinks that it is going to be helpful. So therefore, it's a three-way conversation. You got to have the budget first, make sure that somebody's got the money to pay for it. And then second, you have to have a business problem. It's been identified, business problem that you want to solve. It can't be a science experiment where somebody, wakes up on one day and say, oh, let's just try something new, right? It has to be a valid business problem, agreed upon problem. And then the operator needs to have the feeling that that the solution that we're offering actually does solve their problem. That's kind of how it starts.
Okay. Yeah. And I suppose because you have these two different stakeholders, or like the user and the buyer, are different entities, pilots to some degree are important, but it's a topic that's come up quite often lately. The challenge where a pilot is implemented and then the solution at scale is fundamentally different from the problem being solved for a specific pilot. So pilots maybe in many cases don't scale well. How do you address the issue of maybe having to do a pilot to demonstrate value to both these stakeholders, but then ensuring that the pilot actually will scale and provide also the same the required value across the entity?
Right. So it always, as you've guessed, it always starts with the pilot most of the times, right? That because they want to make sure that we're actually able to run the software in their environment. We can actually connect to their equipment and sensors. We can, in fact, show that we're able to predict the failure condition that they want. So typically the pilot runs anywhere from 3 to 6 months, depending on the customer. But before we get into the pilot, we always obviously have contract negotiations to say that if the pilot were to be successful, what's next, right? We have built, because we have been doing this for the last, I would say, 4 or 5 years now, that some of them are actually running in production large scale deployment as well, that we have enhanced all of our tooling to say, look, it's not just one device, it's not just one machine that you're connecting to. Of course, you can do that in the pilot, but beyond the pilot, if you've got multiple locations, multiple sites, multiple machines, and how do you scale that up? How do you take one of the same solution that you already built to automatically, with one click, deploy this across many sites, and then be able to still further localize and customize to the specific environment? How do you do that? So we built a tool called Foghorn Manager that helps them with large-scale deployments and local customization, and then also things like auto discovery. Many a times to scale this up, for example, to go manually configure a system to list all of the sensors, it's going to be practically impossible, much less, not to mention the error-prone nature of it. So we've got tools built in to automatically discover what sensors are actually available and exist, present that to the user, allow them to be able to customize that solution, and then once you customize it or localize it, with one single click, select a number of these devices at once and be able to push that. Same thing for any updates since then. It's not a one-time thing. From time to time, we might release patches, fixes, bug fixes, maybe updates. It's the same mechanism that happens as well. So we use a container technology mechanism to actually start shipping this to a number of sites automatically without shipping physically the bits and things like that. So we've actually considered all of that, the management, monitoring, configuration tools for scaling up from the get-go. Luckily, we've had big partners, and many of them are investors early on, that helped us to actually test this scaling aspect of it in their environments. And that's how we kind of beefed it up. And of course, we continue to learn from each of these customer deployments and to see if there are other things that we can improve on. And it's an ongoing process to improve.
Okay, great. Very interesting. So let's then turn to the technology, and in particular, this discussion of when to use cloud, edge, or a hybrid system. So I guess you have maybe four terminologies that we should define up front for users that are not so familiar here. So we have the cloud, we have the edge, we have the fog, and then we have hybrid systems. Could you just, in your own words, define those four alternative architectures?
Yeah, absolutely. So let's start with the cloud, which I'm sure all of us are familiar with. And by the way, just early on, back in about 15, 20 years ago, I did my own self-funded startup. It's slight digression here. At that time, people used to call it different things. I called it grid. Some other folks called it utility computing. Ultimately, the word cloud stuck. But in any case, a hosted, centralized data center-like environment where all of the data processing, analysis, computation happens in a central location. It's centralized, right? We know that, right? That's the cloud. We've got major providers, whether it's Microsoft, AWS, Google, and whatnot, right? So that's fairly clear. I don't need to spend a lot of time on that. Now let's talk, before I go to the edge for a second, let's talk about fog, because in fact, we named our company as Foghorn early on. And the context there that about 8 years ago or so, right? In fact, Cisco initially came up with the term fog computing, although they didn't quite execute on that. The concept there behind that at the edge of the network, when you've got assets, manufacturing machines, oil refineries, vehicles and buildings, whatever these things are, they are at the edge of the network or assets. And any computation that happens closer to them, sometimes on the assets or closer to them, is what initially started off as the fog computing. So that's how we, in fact, named our company as Foghorn. You might have noticed that we no longer use the term fog in our any of our references and materials, and there is a reason behind it. So what happened in the last 6 years or so, a lot of folks, as well as standard organizations like OpenFog, which we were part of, and things like that, they started to dilute the definition of what fog computing is. People started talking about, oh, fog is anywhere between edge and cloud. It's a continuum. It's this, it's that. And then, the definition got diluted. So we actually stopped using the term fog. In fact, not many people are even using it anymore. Edge is the definition that is sticking right now. It is simply to mean that is the edge of the network, closer to the asset or the asset itself, where you start doing some computation to identify or predict whatever you're trying to do, right? Now, there is a slight variation of that edge, especially with 5G and the mobile network operators coming in. It's called MEC, MEC. Previously, it used to be called multi-access compute. Now it's called mobile edge compute, or vice versa. And what their definition of edge, which is the other definition that sticks today, is that rather than considering edge as the asset or the edge of the network, instead they consider the edge as the base station, the cell tower base station, where the information of the data from the assets flows into the base station, and that's their edge computing. It's not all the way to the cloud, but it is somewhere in between. That's their edge definition. So we have talked about cloud, we talked about fog, we talked about edge, two different flavors of edge, and then hybrid systems. What is really practical today is actually a hybrid system. Almost every single customer that we have deployed into, that anyone that you talked about, always uses a hybrid system. And because edge is good for what it is good for, cloud is good for what it is good for. When you have a historical data, petabyte scale services, aggregation across multiple sites, site-wide visibility across the whole company, and things like that, some of those services are typically hosted in a cloud. So cloud still has a role what it needs to play for. Edge, on the other hand, is people have real problems. They've got plants, they've got factories, and they've got real problems, and they need to solve those problems right then and there as it is happening. They can't wait for that information to be shipped to the cloud and then somebody telling them back, here is the problem, go fix it. It's probably too late. So most customers install our edge software, deploy this edge software to find the problems in real time, derive the insights, take care of business, and then use the cloud to send and transport these insights from each of these different locations into a central cloud storage, into a cloud service. And that's where the aggregation happens. And that's where any fine-tuning of the machine learning models or further building of the models happens, things like that. So that's where the cloud gets used. Not to mention, dashboarding, central dashboarding, company-wide visibility, and things like that. So most definitely, the hybrid systems is where every customer is choosing to go deploy with these days.
The edge, I suppose, as you said, it can be a number of different things. It can be a base station. It can be, I think in many cases, the gateway is quite common. It could even be a sensor or something with a very low compute power. But because you're dealing with ML and things that require, I suppose, a bit heavier power, is it typically going to be the gateway that you would be deployed on? Or is there a wider range of hardware where your compute could be located?
It is a wider range. Remember, I mentioned our core part of the technology is this notion that we can run in this constrained environments. We have this technology called edgeification. What it means is that typically analytics and machine learning and models that run in a cloud environment that almost assume always infinite amount of compute and storage and memory available. That's not the case in these constrained devices. So we have come up with a number of techniques to edgeify those analytics and machine learning models to be able to run in this constrained environment. We use a number of techniques: quantization, binarization, our CEP, converting all of the Python code into our CEP, number of techniques that we use, both software-based as well as hardware-based acceleration, things like that. Given that, but having said that, normally if you're not doing deep learning, vision-based deep learning, machine learning models out there, in almost about 100 to 150 megabytes of memory, dual core CPU, typically what you would find in a PLC or half the size of a ruggedized Raspberry Pi, you can run a lot of the analytics. But the moment you connect video cameras, audio, acoustic, or vibration sensors, where you're combining them all together and doing deep learning, this is where we need a little bit more memory. So this is where devices like the gateways, whether they are Dell IoT gateways, HP IoT gateways, or Samsung ruggedized ARM-based devices, ruggedized Raspberry Pis, things like that would come in. So it depends on the use case. Deep learning, machine learning requires a little bit more power. We're talking about maybe a few gigabytes of memory, but non-deep learning, traditional, typical analytics, and figuring out you can actually fit it into a PLC or a very small gateway of the device.
We've covered kind of the architecture. What would be you've already alluded to this, but I just want to make sure that this is very clear for everybody that's listening. What would be the decision criteria? So we're talking about latency, bandwidth, certainly cost of hardware, cost of data transfer, and so forth. How would you break down the decision when you're determining what type of architecture fits a particular use case?
I think you started out listing some of those. Those are the right criteria, right? So first of all, we always start with what's the business problem? What's the business impact? Because if it's a simple science experiment, it's not really good for either of us. What's the business problem? For example, it starts a customer comes and says, here is my problem. Every single day, I've got X number of parts coming out as defective from this machine. That's costing me Y amount of impact to the business, right? We've got to solve that. It always starts with a business problem. Now, how do we solve the business problem? Of course, the immediate one obvious thing might be, let's connect all the sensors, send it to the cloud environment, process it, come back here, analyze it, and see what it is. Typically, that's all good if it's a one-time thing, meaning that the problem only happens just one time and that's it. You fix it, you never have the problem again. Unfortunately, that's not the case. It's a continuous problem. What happens is, even when you have a solution, there is sometimes drift in environmental changes, the calibration issues, the data changes. As a result, the same solution may not work. So it has to be a continuous live updates too. And then also, the problem is not solved if you tell the operator after the fact that something happened yesterday or something happened even 1 hour ago. What's the point? It's already happened. How do you predict it and tell them ahead of time, just in time, so they've got a chance to go fix and rectify what's happening? This is where they decide, well, edge obviously makes more sense there. So we start talking from there. And now then comes what kind of data is actually available? What kind of hardware do you need? Is the existing hardware enough to fit it? Do we need to go acquire a new IoT gateway? Is the connectivity exists or not? Those kind of questions will happen. But ultimately, what's the cost of the software for the edge deployment? And of course, it's a total cost, right? Not just the software, the hardware, any networking, any sensors that they may need to install. What's the total cost of that? In comparison to that, how much business problem is it actually going to solve? Meaning that if they've got $1 million, a scrap happening every month, for example, right? If your software is going to cost you $1 million, they're not solving anything too. So there's always going to weigh those two: cost of owning this software versus actual business impact. And then it's not so much about cloud versus edge, as I alluded to here. It's always a hybrid. There is always going to be some cloud part because most customers typically do not have one site; they have multiple sites, and therefore you've got to send insights from each of these sites into a central location. Plus, you will need to do fine-tuning of the models based on calibration issues that are occurring out there. So that hybrid part of the thing always is there, but whether or not it makes sense for them to deploy an edge-based solution is purely directly related to the extent of the business problem that they're trying to solve.
In many cases, people already have cloud environments up, right? So the one-time cost there is not going to be a factor. It's just the cost of transferring data, storing data, and so forth, which in some cases could be high, in some cases it could be insignificant. But then there's probably going to be more of a one-time cost when it comes to deploying an edge, but then maybe lower operating costs. So there's a bit of a trade-off there. But it sounds like for you, it's more about looking from a business perspective, seeing where is the value, and letting that then drive the decision.
Yeah, ultimately the business value is going to drive the decision, but some of the points that you're making up, of course, are still valid, right? So leave aside the initial cost of setting up a cloud environment. When you're transporting all of the raw data into the cloud environment, assuming that latency is not a problem for the customer, that's a big if. Let's say latency is not a issue for the customer, then transporting these, any given typical use case, you've got megabytes to terabytes of data coming in every single day. Transporting all of that into the cloud, there is transportation cost, and then there's storage cost. On the onset outlook, it seems like, oh, it's actually really cheap to store. Just every megabyte is only cost you a few cents and all of that. But what happens over time, over a month, it actually pretty much adds up very significantly, right? And then more importantly, many a times that raw data is actually not very useful after a few hours. For example, if you keep telling my temperature of a temperature sensor measuring for the machine, 76 degrees, 76 degrees, 76, that data is actually not very useful. After an hour, okay, so what? It was 76. What you need to find out in real time as to what actually happened. But you're absolutely right. There are trade-offs. What is the cost of storing this information, and can we afford the latency of transporting all of that? And then, is it quick enough? Is it solving enough of a business problem in real time to do that? So the number of factors that come in, ultimately, Eric, this all goes back to their CFO. Any company CFO is going to look at to say, has it, contributed to my bottom line, in the sense that has it helped the bottom line? Has it solved preventing the losses? That's really how they're going to look at.
And so I want to get to a case study, but just one more question on the technology side before we move there. We have a number of trends right now which could be pushing in different directions, right? So we have 5G that I think some of the cloud architecture providers are hoping is going to make cloud somewhat more real time, potentially even lower cost. And then we have improvements in hardware that make edge computing much more powerful. So what are the technology trends that you're paying closest attention to that will be impacting how this architecture is structured in the coming years?
So we are very closely working with all of the major telcos across the globe, not only here in the US, but across the globe, right? The mobile edge computing, or the MEC as they call it, is real, right? Now, in scenarios where, let's say you take a manufacturing plant, if they've got existing connectivity, hardware, industrial Ethernet installed and everything else, most of the times they're going to run this edge analysis locally there. Now, but with this 5G, invention of 5G coming up, and the notion of MEC coming up, what is happening is that people are going out to these plants and manufacturing customers and saying that you don't really need to install this industrial Ethernet or any of these connectivity issues out there. Simply use 5G, send all of that information into a mobile base station. That's where the compute happens. And these telcos are actually leveraging us too. We're just running our software in the base station as opposed to running in the plant. But the technology trend that's shaping up right now, and I think it's going to evolve quite a bit in the coming year or two, and we're paying very close attention and already working with the telcos on that, would be to shift the edge computing happening in some cases where there's no infrastructure installed back into these MEC base stations. And that's really what's going to happen. So the people will have a choice to make whether they want to go install their infrastructure within their plant, or whether they want to use 5G and actually transport that into a MEC. And then the 5G, because of its very low latency, they would not see a difference. It's a matter of their choice in terms of whether they want to install locally there or have that compute done in the base stations as opposed to all the way to the cloud.
Okay, great. Let's go into one or two of the case studies then. Do you have one in mind that you'd be able to walk us through, ideally kind of an end-to-end perspective from initial communication with the customer through deployment?
Yeah, absolutely. Let's talk about that. So Stanley Black & Decker, you've heard about the company. It's one of the largest tool manufacturers. Pretty much anything you can think about that we all use in house tools they make, right? And we met them, I would say, maybe 2.5 years ago in one of our events at a GE-sponsored event. And they've actually looked at, so they came by, they talked to us, and we've been showcasing the manufacturing problems we solved for GE and, number of others. And then they came and they started brainstorming with us and said, look, we've got a problem too. We've got a problem at, on an average, they've got about 80 plus plants across the globe, as you can imagine. And the manufacturing various different kinds of things, starting from, measuring tapes to tools, to toolbox, to high, powered hammers and all kinds of tools out there. And what they were wondering was when they went to the analysis and they've gone to McKinsey analysis and figuring it out, what exactly is the business problem and so on. It was clear to them that, hey, look, each and every one of these plants is having a lot of scrap. The quality inspection, they only detecting that at the quality inspection time. That was too late. So they throw away all of that. And that's costing them millions of dollars, right? Pretty high value. So when they heard about us and when they came and talked to us to about 2.5 years ago, and then we were showcasing what we have done, similar use cases, similar customer scenarios and all of that, they wanted to do some kind of a pilot. Initially, they wanted to start with, one or two use cases to see whether this is actually real or not. And obviously, right away, we did not get into any contract or anything like that. But initially, they want to understand how real this solution is, because their problem is huge across all of these plants. We have actually publicly talked about it. We've also done joint, seminars and papers and all of that too. So some of this information that I'm saying is actually also publicly available. So I'll talk about one specific use case, which is kind of interesting. So one of the plants in Connecticut, it's called New Britain, and they manufacture, among other things, a measuring tape that we all use at homes too. They have white tapes, yellow tapes. The traditional ones are these yellow tapes that I'm sure you have seen that. And so that tape is actually, they make a lot of it every single day, right? So it's a very high speed, high moving manufacturing machinery. And as they're making this tape, and sometimes what comes out of it, there is extra ink, extra painting, broken markings, or the markings on the measurements are not quite right. Whatever there, 50 different, 50 to 100 different types of defects that can occur. That is almost impossible for anyone to notice. The tape is moving so fast, it's being manufactured and moving at a very high rate. And then it comes out, at the end of the day, it goes through quality inspection. Somebody physically, manually looks at it. Is everything okay on this? And occasionally, they spot it. And if they spot it, they throw away that part right there. If they don't even spot it, it goes to the next stage of distribution center, or somebody else then notices it, and then it's thrown away. That's costing them, millions of dollars out there, right? So they wanted to solve that problem. Prior to talking to us, they talked to another company, National Instruments, for example. They put in a system called LabVIEW, which is basically a vision-based system where they've installed a video camera, and the video camera is pointing to this tape measurement process, the machine, and then closely observing, for example, if there are any defects occurring on that tape. And then they display it on a dashboard. And of course, an operator has to look at it in the dashboard, which is also impossible. Nobody's going to look at it on the screen all the time. But that system is supposed to flag if there was any defect, and so that the operator at least goes and takes care of that. What actually ended up happening was that 90% of the time it was giving them false positives, right? So effectively, they were not detecting anything. If anything else, was actually causing more churn on the operator as well as less productivity, because it's raising false positives. They stop the machine only to find out that was actually not the defect. Something else is the defect. So what we did is luckily they had this existing video camera installed. They've got all these machines, connectivity set up and everything else. That was actually easy. So we actually went and dropped our software onto the same system. They've got the same compute gateway device there. And then we connected our software to that same video camera that they've already installed. It's a high-speed, high-resolution camera doing 60 frames per second. The thing is moving really, really fast. And then we built, using our data science capability, built a machine learning AI model on that live data to detect 50 to 100 different types of defects. And then they've given, of course, I'm kind of simplifying this, they've given several different constraints and conditions as to, well, the defect happens a certain number of times within a certain distance, a certain length of the tape. Here is exactly the slight variation that we're looking for. I mean, there's just so many nuances to that. So we taken all of that into account and then programmed that. And in few milliseconds, remember, this has to happen in milliseconds because it's already too late if it's anything beyond that. We detect it when it exactly meets the criteria, the condition that the operator is interested in. We send an automatic alert to the operator. We automatically display that in the dashboard as well, whether anybody is looking at it or not. And then the operator then goes and tries to stop the machine and then takes that particular process out, fixes that print process, and then restarts it. We've actually eliminated their scrap using this process. Once it's running for several months, then once the operator is comfortable, hey, there are no false positives. It's actually detecting everything correctly. This is what we want. It's actually saving us. Then we actually have, as part of our product, an SDK, software development kit, that if they wanted to automate and programmatically to say, whenever we raise this particular defect, go ahead and actually stop the machine. We don't need to even involve an operator to do that. They're able to do that as well. They can program a simple program using our SDK to programmatically do that. But that level of maturity comes in after deploying and running this for a certain period of time and things like that. So that's one clear use case end to end. And obviously, before getting into all of that, we obviously had a big contract saying that, hey, look, if this kind of thing actually works, we are going to deploy this to similar solution to all of the 80 plants. And so we had a value-based contract created for them. And so since then, parallelly, we've been working on many plants, some here in the US, some in Europe, some in Asia and things like that. So that's the use case.
Okay, great. So it sounds like a great use case and a very common one. To what extent are you able also to run root cause analysis? Right now, we're looking through a camera, so we're basically identifying in real time the problem and minimizing the amount of scrap by stopping the machine and solving that. I suppose, hypothetically at least, you could also take data from equipment upstream and identify potentially what was the cause of the problem. Is that something that you've been able to do or that you've looked into in this use case or in others?
In this use case, we did not, because they did not have sensors for the other one, but we certainly did the root cause analysis. And the other use case, I'll tell you one. Remember the flare monitoring example that I was giving you, where you're processing and refining the gas, for example, and then occasionally, because of the sometimes the pressure builds up in the compressor, there is a compressor problem, as a result of which it's not refining it, and then they have to release the gas. That's one problem. The second problem is there's sometimes they actually take this, what they call the sour gas, and then try to sweeten this using a chemical process. And in that process, sometimes there could be foaming, a condition called foaming that could occur, as a result of which the flare can occur too. While we initially built a solution for identifying if the flare is happening or flare is going to happen, and then the contents of the flare, which is basically the composition of the gases, is beyond certain values and all of that. But then customer obviously wanted to find out, and we all wanted to find out what was actually causing it. Okay, it's great that you're finding the KPIs for the flare and then we can stop it, but what was actually causing it? So then we fed information from the compressor, which is the compressor sound, and then trying to correlate if a bad compressor sound directly correlates to, for example, a bad smoke coming out of the flare. Sure enough, we were able to find that. And of course, it didn't stop there either. Then the next question is, why is the compressor bad? So we took all of the sensors from the compressor, trying to identify when will the compressor go bad or when will the foaming condition occur. So we have done the root cause analysis. As long as data is available, sensors are available, we can get to the root cause like that.
Sastry, so far, all of the use cases we've covered here have been efficiency related to some degree. This is, I think, kind of an interesting topic in the IoT space, which is, let's say, the value of efficiency related use cases is quite clear. And building a business case is often fairly easy to do because you have a real clear cost KPI attached. Then on the other side, you have revenue related business cases. So if I'm thinking about Black & Decker or I'm thinking about an equipment OEM, you could also see them potentially deploying some sort of edge computing solution on their equipment in order to provide a new functionality or a new distribution model, a new business model to their customers. It sounds like this is not a focus of Foghorn today, but what is your perspective on the value of kind of revenue-oriented edge computing deployments in the future? Is this something that you expect to invest in the coming few years, or do you think this is more a number of years away before this is going to be a big business?
So we're already doing that. I'll give you a couple of different examples. Even in the case of Stanley Black & Decker or other scenarios, I'll give you one example, right? On the machine itself, right? How do you know if the machine is properly used? Are there revenue opportunities for producing additional number of products out there, right? So that kind of supply chain management and identifying, so these are all closely related, right? Efficiency of the machine is closely related to if there are opportunities for new revenue lines too. But a concrete example, I mean, in the case of SPD, that's a direct correlation. but a separate, extensive, exclusive opportunity like that. We closely work with Honeywell. One of their divisions is called SPS. They provide, they manufacture a device called Mobility Edge, which is like a handheld, ruggedized device. A lot of the operators, like logistics, retail operators like FedEx, UPS, Walmart, any of these companies, they all use them there. Now, on those devices, I'll tell you a couple of use cases where potential revenue opportunity was there for them, and then now we're adding more use cases. Is that, for example, these operators, for example, scan boxes with the barcodes on them, right? And now what happens is many a times the barcodes are damaged. Either they're not printed correctly, or they're torn, or there's not enough lighting, or something else. Then what happens? The operator tries to scan that barcode, and it doesn't work. It does not decode, and therefore the package gets left behind. It's going to take its own course. And there's business impact to that, significant business impact to that. What we have done now is we run our software on those devices too. We put our first Edge AI software on those Android-based devices, and what happens is, as the operator is scanning this barcode, simultaneously that image is actually sent to a solution running in Foghorn behind the scenes, which reconstructs that image and sends that image back onto the user's application. User is not even aware this is all happening successfully. So this is all again based on EOI. This is additional business impact for that. But the other thing, now that it's running there, now they're saying all of a sudden, yeah, look, Mr. Customer, you've got this device with you already. I've got now Foghorn AI on that. I showed you one solution. Now let's put on additional solutions. Now they're trying to use the same device for health monitoring. Now all of this COVID situation, we actually are just, this is what Kira was referring to. We're going to announce the solution that we just built. Many customers started using it. Health monitoring solution. It can run on the same device. All you need is a device and a compute power and a camera attached to it. We can do social distance monitoring, elevated temperature monitoring, cough detection, mask detection, things of that nature. Now, customers don't need to invest anything other than buying this additional solution. They've got the device, it's already running. Foghorn is already running on that too. So the opportunities for additional revenue channels is quite clear in those kinds of scenarios. And once you have that platform up and running, how do you add more and more of these solutions to the customer to solve their problems for additional business lines?
Okay, great. Yeah, sounds like you're already quite mature in this space. So if you were to divide the market just in terms of the potential, very high level between efficiency and revenue growth, how would you see it today and how would you see it moving forward?
It's hard to tell. Here is why. Because many times its customers sometimes are not as clear to either. They're not going to necessarily tell you they want to do this because they want to increase. It's a two sides of the same coin, right? So reducing the scrap, and therefore you're improving the productivity, you're producing more things, and therefore you're improving the revenue. Now, do you call that an improvement of the revenue or call that an efficiency, right? Customers sometimes, how they bucket this is really hard to tell. That's why I think it's a really hard thing to tell exactly whether they classify this as a revenue increase type of solution or whether the yield improvement option. They're two sides of the same coin.
Sastry, super interesting conversation. I think we're coming at the hour and I want to be cognizant of your time, but is there anything else that you would like to cover today?
No, I think we covered a lot of topics. In summary, what I want to say is that our core differentiation, what we're seeing in the market, is that Edge is definitely taken off, right? 4 years ago, if you talk about it, and everybody's saying, oh, we just need cloud, we don't need Edge. Now, even the same Edge cloud players, which, by the way, we have very close partnership with all of the major cloud partners because we're complementary to what they offer, they're all coming and singing the same tune. Oh, you need actually Edge. Cloud alone doesn't do that too. So I think people have clearly recognized the need for the edge computing and what it actually plays and where it plays well. And then the fact that people do need a hybrid system in many cases to complement what they've got in the cloud is happening. The AI part of it, analytics and machine learning, we have done quite a bit. And the other thing that I would say is that having deployed this in many, many sites now, the problem that we're trying to solve and addressing is this notion of automated closed loop. Once you deploy a solution, it's not going to keep producing the exact same accurate results all the time. How do you continuously update it automatically in the loop? This is what we've been calling the closed loop ML or AI. I know it looks like another buzzword, but it's not really a buzzword. It is how do you automatically update some model when there are changes occurring in the system. So these are the kinds of things, but it's really promising now with the invention of 5G and Mac. I think this is really, really taking off.
Great. Yeah. I mean, this is a super interesting trend. We have a lot of different technologies. So we've mentioned 5G already, but also in terms of ML structures that are really trending in your direction right now. So very positive outlook for Foghorn. Really interesting conversation today. I really appreciate your time, Sastry. Last question from my side would be, if somebody was interested in learning more about Foghorn, what's the best way for them to get in touch with your team?
So I think if they send a message to info@foghorn.io, somebody will get in touch with them.
Okay, perfect. Sastry, thank you.
Absolutely. Thank you, Rick. Great questions. Pleasure to speak with you.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.